This is version 2 of this video. Even if you saw version 1, you might like to watch this version as well. I made a couple changes to fix some confusion. Hopefully it's better now. Let's check it out. Hey guys, this looks like a fun one. We're given an orange rectangle and a black square. And it wants to know what is the shaded area. We're also given that this intersection point bisects the base of the square. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. Let's call the height of the rectangle x. And then the base of the rectangle is the same thing as the top, so it's also 4. And now we can write a formula for the area of this rectangle. It's going to be 4 times x. It looks important. Let's put a box around it. So now let's solve for x. For the first step, let's construct this line perpendicular to the base, or parallel to this side. And now we've created a right triangle right here. And we have another right triangle right here. This is a right angle because it's a corner of a square. And then this right here will also be a right angle. I'm pretty sure that this right triangle is similar to this right triangle. But let's see if we can demonstrate that. Let's call this upper angle A degrees and this one B degrees. Since this is a triangle, we know that 180 degrees minus B degrees minus 90 degrees will equal A degrees. Well, same thing's going to happen down here. To get this last angle, we can do 180 degrees minus B degrees minus 90 degrees, and that makes this A degrees. And then for the exact same reason, since this is A degrees, this angle up here has to be B degrees. And now since these two triangles have all their angles congruent, we know they're similar. Let's label this distance to this point here y. And that would make the entire base 2y, and the height would also be 2y. Does that make sense, y? Now let's focus on the two triangles. Let's copy this one down and scoot it over, and let's copy this one down and rotate it. Since these two triangles are similar, we can write a proportion. We can do hypotenuse over bottom equals hypotenuse over bottom. It'd be 4 over y equals x over 2y. And now from here, I don't really like fractions, so let's get rid of these denominators. We can multiply both sides of the equation by 2y. On the right-hand side, these two 2y's are going to cancel each other out. So we're left with x. And on the left-hand side, this y and this y will cancel each other out. And then we're left with 2 times 4, which is equal to 8. And now we've solved for x. X equals 8. Let's plug it into the formula we created earlier. In the place of this x, let's plug in 8. And 4 times 8 is 32. This shaded area is 32 square units. Keep in mind we did all these calculations without this vertex being on a specific point on this side. So in all the cases from here to here, the area of this orange rectangle is 32. The constraints on this problem were about this vertex being on the midpoint of the base of the square. And this vertex lies somewhere on the top of the square. Nothing else was restricted. This angle was not defined. The size of the square was not defined. So in fact, when we move this left and right, the size of the square does change. And that's totally fine. And in fact, watch this. This is kind of fun. If we go to the extreme case all the way over here, where the rectangle makes up half of the square, we can verify this is also 32. Because if the top of the rectangle is 4, then the bottom would also be equal to 4. And since this is equal to this will also be 4, making the entire base 8. And since it's a square, the height will also be 8. And then the area of the square is 8 times 8, which is 64. And the rectangle is half of that, which is 32. In all these cases, the orange area is 32. How exciting.